We are live on Facebook now. (15:28). Should we open up on the waiting room?
Yes, yes.
डेविड साहब आप भी चेक कर लो माइक. Praveen, can we
Yes.
check mic?
Mic testing. How do you read?
Fine, sir.
Cool. I'm muting it again.
Hello, sir. Good afternoon, everybody.
Good afternoon. Good afternoon.
Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon. Good afternoon.
So can we start with the session, sir?
Please, let's go ahead. Let's start. It's 3:30.
Okay, so it's 3:30. Let's start. Graham. Yes, I can see Graham. So we are live on Facebook now. Let's start the session. Let me welcome the chairman of the Mumbai branch of the Institute of Marine Engineers, Mr. Vijendra Jain, who's a partner of New Tech Maritime, a dynamic personality who just wants to keep doing things for the Institute. By his perseverance, we are able to put up many webinars, technical sessions, and social initiative programs for the marine fraternity. Over to you, Jain sir.
Thank you. Thank you, Sanjeev, and good evening. Mr. Graham Calder, Mr. Praveen Chowdhury, eminent members of the shipping industry who are present here today, colleagues and friends. It gives me great pleasure to extend a warm welcome to you all for this technical lecture, which is being arranged by the Mumbai branch of the Institute of Marine Engineers, India. We are indeed humbled and encouraged by this tremendous response from the marine fraternity for our initiative. The last I saw, there were 497 confirmations. We have had close to 500 registrations for this seminar from across the world. A number of participants will also be witnessing this live on our Facebook page. The IMEI is also happy to have with us Gulf Oil as supporters for this particular seminar. They have agreed not only to share their technical expertise in this subject, but also support us in our endeavor to disseminate technical information. Many thanks to Mr. Praveen Chowdhury and Mr. Graham Calder from Singapore in agreeing to share their time and knowledge and also make this seminar truly an international one. In fact, the time slot selected for this session has been such that the audience over a wide part of the world can tune in and attend comfortably. A mandatory reduction of the sulfur content in the fuel oil being used on ships from January 2020 has brought with it associated problems with regards to lubrication. The significance of testing of lube oils has never been so important as in the current era. The scuffing and the wear down of cylinder liners is a reality which we are all having to deal with today. With such dramatic wear down, resulting in a huge escalation of costs for ship owners, if not addressed properly, it is indeed an appropriate time to educate ourselves further on this sensitive topic. We look forward to the next 1.5 hours of this lecture session, which is to be followed by a series of Q&A. We have received a number of questions from the fraternity, which we have passed on to our guest speakers, and they shall try and address them in the short time available today. The Mumbai branch of the Institute of Marine Engineers has truly taken on the challenge of COVID-19 head-on during the last couple of months. We now have something lined up almost every weekend for our members as compared to, let's say, one every quarter earlier. I shall take 2 minutes of your time to touch upon briefly the activities lined up by the branch during this month of July. After the success of our inaugural Antakshari session, we have planned our sequel, Antakshari 2, tomorrow evening, where we have the very famous and talented, the very well-known Indian Idol winner, Mr. Abhijit Sawant, joining us as a guest singer. From the coming Monday, that is the 6th of July, we have arranged a 3-day online course in hydraulics, particularly suitable for ships engineers and ETOs to help them in problem solving on board. And we are happy to have received a phenomenal response, far exceeding our expectations, with registrations coming in from across the world. This was totally unthinkable earlier. We are planning to arrange our monthly meditation session in the afternoon of the coming Saturday, that is 11th. On 17th of this month, we are in the process of organizing a large conclave on inland water shipping, another hot topic, in coordination with the chairman of our National Shipping Board, Dr. Malini Shankar. On 25th July, subject to the availability of speakers, we are currently planning to arrange a seminar on mental health and wellness for the benefit of seafarers and their families in these difficult times. We look forward to your continued support in a similar way, continued encouragement for all our initiatives. I shall now hand over proceedings to the soft-spoken Mr. T.S. Girish, a senior marine engineer and head of our technical seminar committee. He is the area manager for India, Sri Lanka, and Bangladesh in DNVGL. I request him to take things further. Thank you. Girish, you are on mute. Please unmute yourself.
Yeah, thank you, Jain sir. A very good afternoon to everyone. I have the pleasure to introduce Mr. Graham Calder. Mr. Calder is a marine engineer by background and sailed with BP before he moved ashore and joined BP's UK R&D Center on Marine Lubricant Development. Mr. Graham has held positions in Middle East and South Asia during the course of his career, and he is presently the Senior Technical Manager in Gulf Oil Marine and based out of UK. Well, I hand over to Mr. Graham. I hand over the floor to you, Mr. Graham, and we look forward to a very illuminating session today.
Thank you for the kind introductions, and it is very pleasant, not actually to be in Mumbai, unfortunately, but to be with you. Over the course of my career, I have spent a lot of time in Mumbai and did present and do functions with the institute there in the past, and it was always a very good venue, and people very interested, and as Mr. Jain has indicated, huge interest in today's seminar and your forthcoming hydraulic one, which is really quite impressive and quite remarkable, really, to get that number of people. But this is the beauty of the technology, and we get the global range. People can sign in from everywhere, so even members who are no longer based in Mumbai can sign in. Basically, I'll be going through the whole process of used oil analysis, including the interpretation of the results and a couple of other topics that were flagged up. And then when we're finished, obviously, I've seen there's quite a few questions coming in, and I'm sure there will be more questions that come to mind during the lecture. It probably takes something like 45 minutes or thereabouts, so it gives us plenty of time for questions. And yeah, so if there's no further ado, I will get things going. If everyone can everyone see the screen? Can we see the screen? Can you see my screen?
Yes, we can see now.
Oh, very good. Thank you. Right.
Yes.
The purpose of used oil analysis. This is one thing that people have different views on, but referring it to the normal situation that you get in terms of reports on board ship, the standard used oil analysis is basically to monitor the serviceable condition of the lubricant. Something people tend to forget and tend to look for more deeper meanings, shall we say, and getting things out of it that possibly it's not designed to do. As a secondary purpose, it does give an indication as to condition of the equipment if you look at it correctly.
Mr. Calder, sorry for the interruption.
Yes?
Have you done the share screen, because it's not visible right now?
Oh, sorry. I haven't done that. No, let me, apologies for that. There we are.
Thank you, sir. Thank you. Totally visible now. Thank you very much.
That's good. No, I just there we are. Okay. Yes, that's better.
Perfect, sir. Thank you.
Okay. So as I said, serviceable condition of the lubricant is really the prime purpose of the normal used oil analysis service that you see on board a ship. But you do get an indication as to the condition of the equipment. Again, if certain things are done correctly. Used oil analysis is sometimes treated as, I don't know, people don't treat it correctly. Many people are only really interested in getting the report as long as it's got a green. It's registered normal. They don't really want to know about, something else that's happening. But if it's done correctly, it's an extremely valuable service. It gives you an insight into not only the condition of the oil, but the condition and the operating parameters of the equipment. So there's a lot of benefits. You obviously see the benefit in any change of the physical chemical condition of the oil, its main purpose. Contamination, strictly speaking, there should be nothing else in that oil except for its own chemicals. Identification of where you can actually start to see if you get certain elements appearing in your oil, where is that coming from? And if you're, quick and competent, you can actually control your maintenance costs and failures. Extension of life, oil life. A lot of people are changing oil on an hour basis, but if you're doing used oil analysis correctly, there is no need to do that. You can keep it going as long as it's in a fit state. So there's a cost there. It prevents unplanned maintenance because you're actually looking at what's happening in the operation of the machinery. And this is where regular sampling, also on-board sampling with test kits, and we'll come to that later, is a very useful parallel kind of look at what's happening. And you can do different things, and we'll touch on that later. In maximizing the engine or the component life or the machinery life, time between overhauls, etc., that is feasible. Monitor the effectiveness of your filtration and purification, depending on where you take samples. And that's something which is another option. Some people do it, others don't. And, obviously, if you're getting fuel into your, certainly in an engine, you can't detect that you've got leaking fuel as a first stage. You may well have to do further investigations and further testing, but you are getting an insight as to, something's going wrong here. Sampling procedure. People, I'm afraid, don't really pay enough attention to this. You need to take a truly representative sample. The old computer adage of garbage in and garbage out is absolutely the same here. If you don't take a proper sample, then you won't get a proper result. And you may end up costing yourself money because oil that's otherwise fit for use may well be condemned. You need to use the same sampling point every time. Use labels. Excuse me. simple labels. It doesn't have to be complicated, but the same sampling point, so that we're getting the trend. The trend is the key thing in use oil analysis, seeing what's happening between what you've done in the past and taking it forward. Are things getting worse, getting better, staying the same? Really, fitting sampling cocks or valves should be a must. Unfortunately, on most ships, the sampling points, other than one or two places, are not there. And that makes sampling difficult. It is very easy to go up to a machine with a sampling point and take a sample, if there's a sample cock. If there's not, people are into splitting lines, gauge connections, all sorts of things. And that puts people off taking the sample, and it puts people off taking it correctly, because they're in a hurry. It's too much fiddle. Maybe it's messy. You know, sampling cock, very easy. So it is worth going round, deciding where the sampling point is going to be, and fitting cocks if it's at all possible. And I've seen that done on ships, and it changed absolutely the way that the whole company actually took use oil analysis. It went from being a chore, a difficult task, to a simple task that produced really good results. Ensure the system is at its correct, I said operating temperature here, but really you're also talking about its operating conditions. You want it to be representative. Flushing the sample point or the sample line. It depends on the system, and depends on how long the sample line is. If it's quite lengthy, you need to flush it through, because what happens is that debris and things collect at the sample point. And if you just take the first oil that comes out, you're actually not getting a representative sample. You're just getting the debris at the bottom. And it's very obvious when we get samples. You can look at this and think, no, that's not a good sample. And often as not, we go back and suggest taking another sample. The next sample comes back, and there's nothing wrong with the oil. Completely different. It's the same oil. It's just the sample has been taken correctly. Once you've flushed through, draw it into a proper sample bottle or a defined sampling container, and then transfer into the sample bottle. This depends on where the sample point is and the convenience. If you're using a sampling container, using a clean plastic container, ideally you would have the container specified just for that, not to be used for something else. But I know what it's like on board ship. People are looking for containers, so they grab whatever's around. Please don't use old tins or other things that have contained something else, because that can influence the results. And occasionally we see samples where they're registering an element that's not anywhere in the system. So where does that come from? So sampling procedure is extremely important, and we give full instructions in the sample test kits and online. So really should be no excuse for not taking a correct sample. There's a typical sample point and a sample kit. We have a very simple sample point label, nice bright color. It's identified. You put it onto the point, having written on the sample point, the grade, and any other information that you wish to put on it. And that's quite important, because when you're filling in the sample bottle label, we need to put a lot of information on there. And this means also as well, anybody can take the sample. If it's all beautifully set up and all labeled, anybody can go and do it, as long as they follow the instructions. Sampling, different ways of doing it. The thief bomb is a very useful piece of kit if you're trying to take samples in a tank and you want to check the bottom, top, and middle. Sometimes, you know, there are occasions where layering, particularly if samples have been mixed or oils have been mixed. Sometimes the sampling access is very limited. So one of these little thin ones is very useful for going down through sounding pipes, etc. I've seen one ship, a huge container ship that had a 200-ton cylinder oil tank with no way of taking a sample of that tank. They had no drain cock. You couldn't even take the lid off the top of the tank because the lid was in the side of the tank. And the only way they could get samples was to go out onto deck and make it, had a homemade thief bomb, bit like this thin one here. The vampire pump is a very useful one, particularly where you can take samples from either small storage tanks or small system tanks, like hydraulic tanks. Take the lid off, you can put it in, and you can get a sample from the middle of the body of the tank. Equally, the piping comes in different tube diameters, so you can't actually take a sample out of relatively small engines through the dipstick tube, which otherwise you may not be able to take a sample at all, or resort to some rather bizarre methods. So those are quite useful pieces of kit. The vampire pump in particular, you just screw the bottle on the bottom, the oil gets sucked up straight into the bottle, cap the bottle. It's very, very straightforward. Sampling points. What are we trying to take for the sample? What are we trying to find out? Is it the condition of the oil? Is it what's in the oil? After you've come through an engine, what's happening in the engine, or what's happening in the gearbox, or whatever. So live samples from a full flow line is absolutely the best, most representative way of taking a sample. Return lines are good if you want to check for wear metals and contamination. Obviously, before and after purifiers or filters can give you an indication of how they're working. That's something that we see quite a lot in certain minor systems. People forget to change the filters. So the filter basically gets blocked up, and you suddenly start to see an increase in debris, which is probably normal wear debris, nothing to get worried about. So you make that comment that, check the filters. The next one that comes back, oil's in great shape because they've never changed the filter. And when we visit ships, and we ask people, when did you change this filter? When did you change that filter? Often as not, they've completely, don't know. Oh, we forget about that one. It's a system that doesn't cause them problems. Bizarrely, steering gear is one that seems to suffer from this. They forget about it. Lube oil reservoir, like a hydraulic tank or header tank or something like that is a good place to get a sample. Lube oil pump upstream of filters. From a lube sump drain, not really a great one because you need to really flush that out because you get a lot of debris sat at the bottom. I've seen people taking samples from steam cargo pumps, and they're taking it out of the drain plug, and they say, oh, it's got an awful lot of water in it. Well, yes, it will have. A, you should have been draining the water out regularly, and B, that is not the place to take the sample. So you have to think about that. Just some indications here of a kind of engine setup. If you want to check the oil and its condition, then you take it where the sampling point is shown as it goes into the engine. That way you know that the oil that you're putting into your engine is good. However, if you want to see what was happening after the oil had gone into the engine, you might want to take another one after the engine so that you can actually compare the difference and see what's coming out of that. Is there any wear happening or excessive wear? Obviously, purifier, you can take the before and after sort of thing. And it really depends what you're looking for from the analysis. Is it just the oil or a little bit more? Are you looking at engine condition or machinery condition? Hydraulic system, similar sort of situation. You can take it from the reservoir or take it before it comes into the reservoir, or equally, depending on the system. And that this is, I know, an issue. Some systems, accessing sample points is relatively easy, or getting samples. Others, you have a power pack type of arrangement. Getting a sample point there is extremely difficult. excuse me, a little bit of a throat this morning. So, you know, think about what it is you're looking to find out from it. Gear cases, again, you're checking here. We're checking the oil going in for quality of oil, but equally, you know, taking a sample here on the outlet or in the reservoir might well give you an indication of what's actually happening in the gear case. Are you getting any spalling? Are you getting any problems there? Of course, all of these things are in conjunction with the normal monitoring activity on the machinery. So this is UOA is a complementary thing. You know, you'll get hints from maybe various places as to conditions in your machinery. UOA does give you the advantage of sometimes giving you a little hint that you should be looking more closely at something, possibly even checking, you know, sort of magnetic plugs, just looking at the physical condition of the oil, etc. So that's sampling, and I can't underscore how important taking a correct sample is, because if you don't take a correct sample, it's a waste of everyone's time. You don't get the right answer. You know, often as not, we get a sample that looks, you know, 20% water. We would go back and say, take another sample. This is not a good sample. Equally, because people don't like to see on the LUB report the action or the critical or whatever. They don't like the red one. People do send us in samples which are clearly not live samples, shall we say? You know, and it's very obvious when you look at the report. Anyway, this is the kind of standard report. Most companies offer the same thing. Key bit here is just the company, all the company name, all the details. Equipment serial number is a nice to have, but not necessarily. Depends on the situation. Sample location is very useful to know as when you're looking at this, because that can give you an indication, you know, maybe not such a good sampling point and expect something to be different. Obviously, equipment make and model, because that is very important, because that sets the parameters against which the analysis results are vetted. Because everyone has, you know, MEN is slightly different from Vatsila, somebody else is different, you know, the 4 strokes, they're all slightly different parameters for all these analysis tests. So we need to know what that is. The sample information, this is also very important, and this is what comes on the sample bottle label. We have, our labels are in 3 parts. One part is kept by the ship. One part is just the number, which is stuck on the bottle. And the third part is the label, which is kept with the bottle, but not stuck to it, with all the information. And it is absolutely important that all that information is put on there, because the more information we have there, the better the analysis result will be in terms of the interpretation. So, sorry about that. You know, we do need to know, and I know it sounds stupid, but we'll have the sample bottle and sample number, because that's already been put on there. And that will be done as well by the laboratory. And be aware that when this bottle goes to the laboratory, all the data that's on the label is entered into the computer, and then the label is dispensed with, and the only ID on that bottle is the number. So sticking the label, the number label on the bottle is very important. We need to know, you know, what is the oil. Often we get samples, it doesn't say anything, or it says engine oil. What does that? Fuel in use is useful, you know, particularly, you know, I know we've gone to 0.5% sulfur, but we've still got lots of people out there who are running scrubbers, so it is useful to have that.
total machine hours is good because it gives us some indication of, you know, how old that engine is in a sense, how its operational age is. Lubricant hours, as you can see on this one, some people have put them in, others haven't. It gives us an indication, particularly on the 4-strokes for the generators, you know, when oils have been changed, or if we're getting a bad result and it's got 3,000 hours on it, then yeah, okay, you can understand that oil is getting to the end of its life potentially. So that's a very important section that people sometimes don't complete properly, because that feeds into the analysis, interpretation, and comments that will come back. Then into the actual results, the oil analysis. So onto this one, it makes it easier. So you've got the oil analysis section, which is, and that varies by machine. So engines will have a different test suite to hydraulic oil to gear oil. Some tests are common to every oil, and others are more specific to just engines or to hydraulics, etc. So viscosity, generally at 40 and 1, well, always at 40 and 100. Viscosity index, which is of course basically how, and it's just an indication of how consistent the viscosity is kept over temperature. Hence high VI, high viscosity means even over wide temperatures, the viscosity of the oil will, with temperature, will stay, you know, reasonably consistent, rather than dropping off quite dramatically as it warms up. Soot content. There are various, some it's soot content, sometimes it's soot content in solubles. There's a variety of tests on this, and we'll come to that shortly. But basically, this is showing what sort of debris is in the oil in terms of soot, and that sort of you know, poor combustion type of indication. Water content, well, you shouldn't have any water in there. Again, there are limits to how much, but you know, an ideal less than 0.05 would be a very good answer. Nature of the water is just, if we have water, occasionally you can be seeing it's, whether it's salt water, seawater, or sometimes it's there's an indication that it might be cooling water. And base number, of course, or total base number as it used to be called, which is very important in the engine oils, because that obviously has a life. It does get altered, of course, by people topping up. In the past, when engines were maybe not as tight, shall we say, as they are now, with larger sumps, the oil charge its BN would drop fairly quickly to a certain level, and then it would plateau because the topping up would keep the BN level refreshed, and then eventually, of course, it would actually die off. But basically, you would get this plateau point fairly consistently because you were putting in a top-up oil fairly regularly. In some engines, because they've got a small sump and they're quite tight, there's no need to top up. The base number gets heavily depleted, to the extent that on some engines you can actually have an oil that's perfect in every other way, but has insufficient BN and has to be changed. You know, and there aren't really any other ways of you know, increasing the base number, other than some people will run instead of a 40-40 oil, they will run a 40-55, and that just gives them a longer period because they're starting off with a higher base number. But that's a bit engine specific. Right, elemental analysis. In some respects, you could say that this is the stuff that shouldn't be in the oil, and this is the indication of contamination, shall we say, or wear products. The classic one, which you can see at the bottom here, the vanadium, was an absolutely excellent indicator that you had heavy fuel in your oil.
because apart from one or two small components that might have vanadium in them, vanadium only came from one source, and that was the fuel. Unfortunately, when we go to the 0.5 fuels, because of the structure of the fuels and the components they use to make those fuels, vanadium is no longer such a good indicator of having fuel contamination. It's also interesting to note that nickel, which obviously is used in a lot of components, is also linked to vanadium. So when you see an increase in vanadium with fuel, you will see an increase in the nickel content as well. PQ index is just an indication, it's just a number of ferrous magnetic particles, big ones. And I'll come to that a little later on. So basically, all of these results in terms of element analysis, if you have a big number, that's not good. There are some limits set for elemental analysis by OEMs, but not many. So most of these are set on the basis of experience by oil companies and possibly and guided by those OEMs who do indicate levels that are acceptable or not, as the case may be. Wheat and Gulf tend to have certainly a more conservative view on limits, so we have lower limits because, for instance, PQ index of 100, we would alarm. Other people I know, other companies were happy to go up to 400. But on the basis that this is you shouldn't be having anything like that. If you have a wear problem, you're better to know about it earlier rather than later, so you can do something about it. And the same applies to all the other elements there. Silicon is an interesting one because we all see silicon as sand. But in actual fact, in the tests carried out here, silicon can also get picked up as siloxane, which is an anti-foaming additive put into some oils. Often as not, it does indicate there's been contamination with another oil that maybe shouldn't be there. So it's one where people, they react, I've got a very high silicon, but then you have to look at what is it and do some other checks. Check your filters, etc., to see if there's what's in the filter. Have you got debris there or not? At the bottom are the recommendations. These are from the lab, and these are guidelines. People get a bit upset sometimes when they're told they've got high water and there's 3 or possibly 4 recommendations as to check where the water's come from. And these are just heads up, telling you this is where it might come from. It's not saying you've got water leak in all these places. It's just saying common places where water might come from in this engine or this machinery. Have a look here first. And these are standard comments, and sometimes they seem a little bit odd, to be fair, but they are just there as a guideline. We also send out, when we send out the reports, the engineer will also look at the overall report and put on an email maybe some other comments as well. So particularly if you can see the history of the analysis. History is very important. Trend is very important. What something is doing, whether it's increasing, decreasing, staying the same, that's what you're really looking for. Exact numbers are not so relevant, to be quite honest. It is the trend against performance that you're really looking for. So moving on, test slates, test methods. This is just what's a test method? It's a definitive procedure that produces a test result. There are thousands of test methods, different standards. You've got ISO, IP, ASTM, which is the American Society for Testing and Materials. There's Navy, military has different test requirements, etc. So what we're looking for here in the laboratory testing for normal use oil analysis are tests that can be done quickly, cost effectively, and are accurate. But not necessarily the most accurate, but accurate enough for the testing that is being done. If there is a deeper investigation, there are other test methods that can be used, because then we're probably looking for a particular, we're looking for a particular parameter or something that's actually happened, rather than taking a view of what's in the oil, which is what we're doing really. These are the sort of test methods we use. Appearance. Now, people say, oh yeah, appearance, but actually that is a lot to be learned from that. You take your sample, you hold up the bottle and look at it. Is it clear and bright? Is it cloudy? Is there any sediment in it? Is there any solid water in it? All those sort of things. That's your first view. Color. I've taken samples on a ship, and on one piece of equipment, hydraulic equipment, the oil was almost black, very, very dark, and it should have been a light straw color. And the same oil in a different machine, perfect. So what's happened there? Have they got the wrong oil in there? Have they corrupted it with something? Has it been in there too long and it's just degraded? Who knows? But that's the site. The KV, as I said before, viscosity is the most important criteria of an oil. So very important. We have water, obviously, soot insolubles, various methodologies for that, and we'll mention that later on. Flash point. This is quite important because this is really down to fuel ingress. And that has obviously helped, big safety issue there. Acid number, degradation. Base number, really just seeing how your oil is progressing. ISO code, particulate. Become more important now. Well, it's always been important, but become more important now in engines because of the hydraulic system in certain two-stroke engines with these FIFO valves, etc., and they're very tight clearances. PQ index, as I said, measuring larger metal particles, and we'll come to that. And elemental analysis, the ICP, that's just checking what's in there. And we'll come to that later on as well, just to give it a bit more background to the test methods. One of the things you will, I think, you'll realize is that for those of you who are familiar with using the onboard test kits, you'll realize that what you're using on board and what's being done in the lab are, there's a significant difference in sophistication. So do not compare direct results. The trend taken by a test kit on board, if done correctly, will follow the trend that a lab reports will do as well. Yeah, that's fine. But if you try to do a direct comparison, it won't work because you're using different test methods for a start off, and the sophistication in the lab is far superior, I'm afraid. And of course, these machines are significantly more expensive. Elemental analysis, range here. Obviously, things like iron, wear, lead, tin, sort of bearing, said vanadium and nickel, generally fuel. You get the barium, the boron, calcium, magnesium, and zinc. Often just additives. Some OEMs insist that these additives, these elements are in every engine report because they want to be able to check the additive content, if you like, of the oil. A lot of other things in there shouldn't be there. Basically the ideal one is you wouldn't see, apart from the additive one, everything should be sort of less than 1 or very low. which is the giveaway when we get an engine oil that comes in and everything's less than 1 and they've just done an oil change. That is not possible, even if you've done a very good job in cleaning, etc. By the time you've put your oil in and it's done a couple of circles, a couple of circuits, it will have picked up some iron and some other bits and pieces. It will not be less than 1. It might only be 5 or 6, 10, whatever, but it will have something. So if a sample comes in showing nothing, you have to question the validity of that sample, I have to say. Parameters. Viscosity is absolutely the most important property of a lubricant. There is some degree of flexibility, obviously, when we are looking at, for instance, hydraulic oils. You know, you might have 5 different hydraulic oils in a ship, and that can be very confusing, and so people want to rationalize. So on occasion, you can say, yeah, okay, well, we'll put, if you've got, you know, 46, okay, we'll put that in and that'll do instead of the 68, or, you know, this sort of thing. And you bring it down to a manageable level. So you've only maybe got 2 or 3 on board. You know, 15, maybe a 22 is good enough, because you've got other things there. Or you've got one machine that has a requirement for 1 grade. Possibly, you know, you can get away with going 1 viscosity grade higher or lower. Synthetic oils, they absolutely can go one above and 1 below within the range of the synthetic. That's not a problem at all. But, you know, believe me, do not put an ISO VG 150 oil into a hydraulic system that requires a 15. It doesn't work, I can tell you. I've seen the results. You know, so there is a little bit of flexibility there, but not a huge amount. Yeah, viscosity measurements are always tied to temperature measurement, to a temperature for consistency. So engines generally at 100, and then other oils generally about 40. And if you know the viscosity at 100 and at 40 for a particular oil, you can work out the VI and do nice things like that, should you wish to do it. Viscosity increasing. So you see your viscosity, you start off, say an SAE 30, which is roughly 100. It's going up. Why is it going up? Oxidation, it's getting old. Water content upsetting it. Engine oil could be soot insoluble, so you've got poor, you could have, you know, blow by, you could have poor combustion, all sorts of things. Somebody's put the wrong oil in, happens quite frequently. Particularly when people don't label the oils they've got in store. You know, they've got some old oil in an old oil drum. To be quite honest, if you've got those on board ship, use it or lose it, because that's where problems come. You know, I've been on so many ships and there's this old oil drum and you ask somebody, what's in that? Oh, I don't know. Or we think it's so, or there's a felt marker pen being scribbled on it. Something like that. But nobody on board that ship knows what that oil is. You've got a rusty old tin, you know, or used but good. If it was good enough to be reused, don't take it out. If it's not good enough to be used, dispose of it properly. The number of steering flats that have got this mishmash of unmarked tins, of poorly marked tins, you're just, you know, you're waiting for a disaster to happen. Of course, fuel dilution with heavy fuel oil, you know, you start to see it go up. And it can decrease the reverse if you've got distillate fuel dripping in, or solvents. We've seen that. Cleaning fluid has got into it for some reason. And again, someone's used the wrong oil for refill or topping up. Again, it could be, oh, that's an old engine oil drum, that'll be fine, put that in, and you find it's not. It's an old something else that could be up or down. So, you know, again, you're getting indications here. This is how it's measured nowadays. This is a Hulon tube. There are various shapes of this, but basically you have a water bath with these tubes in it, and these are all automated now, can do better than 1 a minute for a whole cycle. Basically, the oil comes in, It's heated up very quickly. It then drops down the tube between two sensors. That measures the time. It's then converted into, it knows the flow. It then converts it into the viscosity. It's then purged, cleaned, and the next sample comes in. There's all manner of different tube shapes, but they're all basically the same thing in this type of viscometer. Which, when you see your viscocomparator in your onboard test kit, you realize, you know, one is not quite comparable with the other. Water. We don't want water in oil. Simple as that. Apart from you get emulsions, rusting, corrosion, you can actually get mechanical malfunction. You know, in hydraulic systems where you're getting high pressures, water doesn't compress. So, you know, you can get damages. And you can leach out some of additives, which then the performance of the lubricant itself is no longer doing what it's got to do. And you're going to get wear or lack of performance, etc. So, you know, and I say to people, you should be checking for water. You know, check your tanks, checking, you know, winches, etc. Just have, if you've got drain out the free water. Just that alone prevents it building up. It's not good to have it there, but at least you're not allowing it to build up. This is the kind of traditional water test. Well, it's not traditional. This is the Carl Fisher titration method, which is used, very accurate. Again, nowadays all automated. It uses perchloric acid, excuse me, titration. And again, electrical monitoring, and you get an answer. It's all done in the box. And most of these boxes actually in a lab are all connected up, and so the results are instantly fed into the main database. There is a quick test called the crackle test, which you heat the hot plate up to about 180. You have a little, people use either a plate or a little disposable cauldron, as they call it. You put a couple of drops of the oil on it, of the sample, and if there's water in it, the water will heat up and like steam, and it will literally crackle. And then you know you have oil, you have water in your oil, and you need to do a test to find out how much. Some people actually can judge the degree of water in by the degree of crackle up to, you know, just a small amount, but they can look at it and say, oh, that's, you know, whatever, 0.1 or whatever, because they've been doing this for years and they've got the experience. But normally it's just a quick test. Have you got water? It's a go, no go. Doesn't crackle, no water. And that just makes it quicker. Soot insolubles, you know, you get the buildup of soot in the engine, and especially you get with, you know, combustion products, incorrect combustion, poor sealing, oxidation, you know, blow by, wear debris, extraneous dirt gets in there. People, you know, it's amazing how dirt gets into stuff. Maybe they're not using the filters. Anyone who's used a glacier filter will know how much stuff comes out of that oil. And it's a very simple centrifugal filter. You know, you'll get something like a centimeter, 2 centimeters, maybe on a big one, of debris. That's just taken out, and that's just a simple thing. So it's, you know, it's in there all the time. It needs to be taken out, and you need to know about it. Now, I've got at the bottom here full details available on the website. We've got a whole lot of technical memoranda that are freely available, do with all sorts of things, from 2020 stuff to additives to you name it. It's all there. It's free to download. Have a look at it. So I'm just mentioning, because it was mentioned in one of the things, one of the early meetings I had with the Institute was FTIR. What is it? You know, you can use FTIR for finding insolvents, insoluble particles, etc. And basically what this is you scan the sample with infrared light. It's quite complicated. I mean, there's lots of information online about it, but you go through this thing called the interferometer, which splits up the light. It goes through the sample. it then goes to the detector, and then there's this Fourier transformation. And basically the information, the wavelengths, if you like to call it that, are converted into this spectrum, and these various peaks are related to different materials. And so you can see what's in there and the quantity. So a small peak, not very much; a big peak, a lot. There are different ways of doing this. This is not the normal way that we would do it on a normal analysis, because it's expensive and it's time consuming. We tend to use an enhanced spot-to-spot test where you literally drop oil on special paper, allow it to filter out. The similar context to that which is done on the onboard test kit. That's the type of machine, and that's the kind of output that you get. So again, it's like a lot of these lab things, you don't actually see anything once you put the sample in. It's all done on screen. Flashpoint test, this is indicative of a fire hazard. The place where we normally see flashpoint tests fails are emergency generators, because they sit there not being used and they're on distillate fuel, and the distillate fuel drips in and gets into the oil. And I mean, if it fails the test, it could be heavy fuel oil failure as well, but normally you would expect it to be distillate fuel. And again, if you're suspecting heavy fuel contamination, you would be seeing that on the vanadium in your analysis. Two different kind of types. There's an open cup, the Cleveland one, or there's an automated closed cup. The closed cup gives a lower flash point, because basically all you're doing is heating it up. When it gets to a certain temperature, you then put an ignition source to it. If it ignites, that's the flash point level, and you want it to be above 180. Under normal circumstances, you start at 180. If it doesn't flash, you don't go any further. The automated ones, of course, make it so much quicker these days. Acid number is just a titration, and that's just oxidation, deterioration. The higher the number, the worse the oil. Base number, really just for additive depletion. You know what the BN is there to do. It's there to mop up the acids of combustion. So, you know, if you're using a high acid, a high sulfur fuel, you will mop it up faster because you're creating more acid. Hence the change of BN levels in the oils for the post 2020. It's also used as a quality control test elsewhere. It can increase, say, you get contamination, you'll see your system oil start to go up, and sometimes goes up quite high because of worn piston rod glands, and you're getting that scavenge space, unused cylinder oil coming down in, and on some, and you can go up as almost as high as 30. I think most of the OEMs are happy with 25 to 30 as being the top limit on a system oil, although that would be most unusual and would not be recommended. Can be decreased, well, it'll decrease because you're depleting the additive, or you've got the wrong oil in there for the fuel that you're running, or you're getting excessive blow by, you know, there are, you know, but it's a good indicator. Again, it's a titration, automatic, when the equal point comes in, the equalization point comes in, that's it, that's the result, quite straightforward. The one done on board using the bomb is very good too, actually. It's quite, it gives you a good indication if the test is done correctly. ISO code, cleanliness. Basically particles in the oil. Several methods. 4406 is basically is an optical method. 4407, which has been requested by by MAN basically, is done by physically looking at it. Someone actually looks at it and counts the particles and the shapes and sizes. Therefore, it's more expensive. and that's a request. 4406 will be done, or the equivalent. They use a slightly different one now that's again faster, but does the same sort of job. And you get you're looking at the 4 levels, the 4 particle sizes. Very important, the cleanliness, because you're getting all sorts of debris in there, where obviously construction debris from new piping and stuff in a new system, they don't clean the pipes properly. Dust and dirt that's got in because you've left things open. Fibers from rags, that's a favorite one. People use rags and there's bits of, well, quite often leave complete rags in there. And then sometimes reactions if oils are incorrect or something else being put in there. That's the famous ISO code cleanliness with the numbers there on the left. Just be aware that every time you go up a level, you double the number of particles. So, oh, it's only 1 level up, but fine. It's 1 level up, but it's twice as many particles. That's a kind of traditional standard particle counter optical one. That's just an example of, you know, there's at the bottom left, you've got a high filtered one, a 14, 13, 11. So that's very, very clean. Typical one, 2018, 16. New oil from a barrel, 2018. So, you know, barrel cleanliness is an important thing. And then you've got another system that's got contaminants, you're quite high. So you can see there's a definite difference there. This was just a comparison, really. What sort of systems, if you've got a very high ISO number like that, 232117, you know, it's a low pressure system, large clearances. It's not very critical. Then you've got your NAS equivalent. That's the American system or an American system. Yeah, so once you go down to high performance stuff, super critical, you're really having to have super clean oil. It's as simple as that. We do not on board ship look after our hydraulic oil well enough. PQ index basically measures big particles. The elemental analysis only gives you very small particles, maybe depending on the type of machine you're using, maybe up to 8 microns, something like that. Small pieces. The particle, this will pick up all the particles as long as they're ferrous, but they have to be magnetic. It will not pick up non-magnetic iron particles, which are the products of corrosion. And I'll come to that a little later. So you're getting, you know, it just gives you an idea. You know, again, it's a big number. If you've got a big number, it's not right. Something's wrong. You need to be checking it. So you're getting a little advance notice that something's going on, and it might prevent. You might be able to stop seizure or failure. This is a typical lab PQ analyzer. Basically, you have 2 coils, and it's the imbalance caused by the 2 coils. And the imbalance is caused by the metal particles in the bottle, which is put in upside down. As you can see on the machine there, it's upside down. Then the table rotates. You get this out of balance signal, and that's converted into a number, which is related to the number of particles. It doesn't mean there's 100 particles there. It's just a scale. The actual Analyx itself will be calibrated from 0 to 750. So that's the kind of range. You really do not want to have something up in the high hundreds. You have a serious problem there. ICP, this is for elemental analysis. ICP is inductively coupled plasma mass spectrometry. Basically, this just uses a plasma, and you inject the sample through a nebulizer, kind of a spray, kind of like those things that people take if you've got, you know, lung problems or asthma. It goes in, and you're generally using argon gas that's heated up, and it breaks it all up into the various components, because you're getting like wavelengths coming out, and that's converted again in the machine to either a picture or just a table of results. You can be selective what you want to measure. This is very, very, very sensitive, and is used actually in the Olympics to test for drugs, or if athletes are taking drugs. That's just the atomizer. Not such, originally that was quite a good photo, but it's got a bit blurred somehow. I'm not sure why. But basically that's kind of the inside. Very, complicated machines, but give a very good result. So that's, I'm just going to, so that's really the lab end of it, where it's coming from. You see the complexity and the sophistication in there. Now, I have a particular beef about the next one, which you've seen before. This is the lubricant's friend. This is the most maligned piece of equipment on any ship or on most ships because people don't run it correctly. If you run your purifier, be it fuel, but lubricant, you've got to get the temperature up. It's got to be up, 95, and you'll get a good result. If you do it at 85, at 80, 75, I've seen, you might as well switch it off because its efficiency is all down to the temperature you keep it at and the flow rate to a certain extent. So you really should be looking at getting this working properly because this is what's going to get big payback. If this is working properly, you will keep your oil in really good condition. And I've noticed that with the modern fuels, post-2020, I've seen quite a lot of fuel reports, and they are mentioning a range now, quite a range of purifier temperatures for fuel oil purifiers. Not the standard, very high, can be quite low because of the componentry that they're using to get the 0.5. So it's worth looking out for that. Right, interpretation. I realize we are moving on here, but hopefully we're getting through it.
Graham, how much time do you think more for the presentation?
Oh, and let's say another 10 minutes.
Okay, 10 minutes.
Yeah, sorry. Let me just take a little drink. I have covered some of the stuff before, so it'll be quicker. Right, here we have the typical report. Viscosity, of course, is very important. Basically, once your viscosity's gone, you have to replace the oil. You can't do anything with it. What you can do is prevent the viscosity getting bad by looking after the oil. Base number, again, once the base number drops down, there is little you can do with that. As I said before, you can actually start with a higher base number sometimes, but that's really just a temporary. It's not a real fix. So nickel and vanadium, they are componentry, but basically it's from the fuel. This is a system oil report. Where do we get the limits? The limits are from the list you can see on the left there. I'm not sure which engine manufacturer this is, but they all produce something like this. It's in the handbook on board. And this is what's fed into the system, and there are variations from engine manufacturer to engine manufacturer. So so that's where that one's come from. That's your BN. Wear metals, again online we have all these little pictures with all the contaminants. There's a whole list of there, and an interpretation list we supply with the use oil analysis kit, so people can actually look at that. So your bearing bushing. So when you start to see increases in elementals, start to look at which ones it is, because that's going to give you an indication of what might be failing. Normal wear is there, but if it gets over high. If you get a situation where you have a different, if you look at your ion from your elemental and your ion from your PQ. If your elemental is low and your PQ is high, you have got abrasive wear. You've got physical wear, abrasive wear. If you've got a high ion elemental but a low PQ, it is likely that you've got cold corrosion, because cold corrosion is small particles. It's a bit rough and ready, but if one is significantly different to the other, it gives you an indication of what's kind of happening. If they're both similar, then you've got a bit of both, basically. It's kind of normal. That's just human hair, 50 microns. So we're talking small particles here. Contaminants, sodium you get from seawater or from, normally it's seawater, cooling water possibly, it's jacket water. Once you get sodium in the oil, you can't get it out. You can get the situation like we've got where you get high sodium but no water. The water's evaporated off basically. It's gone, but the sodium will still be there, and you can't get rid of it. All will happen is it will dilute as you top up, as you lose oil and you top up. So boron, again, it's kind of an additive in some things, so you wouldn't expect to see that. Silicon, as I mentioned before, it can be shown as dirt, or it could be as an anti-foam that's come in from an incorrect oil that's been put in there. Anyway, grease, lithium would be showing, molybdenum also in grease and anti-wear. So there's a lot of things there. Hydraulic oil. The little pictures here, you're just seeing the bottle on the left has got free water. Then you have gone to an emulsion, and that's what it should look like if it's clean, clear. And again, an old oil and a new oil, you can see the difference that happens when it gets degraded. Really, we should be using desiccators on all the breathers to prevent dirt and water, moisture, vapor being sucked in, but we don't do that on board ship. You can get them, you can put them on drums, you can put them on small header tanks, and you get them, and they will color change when they are spent. They filter out the dirt and they filter out the moisture. So acid number, that's basically telling you how degraded it's going to be. Particle count, again, when you see it, you've got your number there. We're doing 4. Where is that on the list? And you can see that. So that's the 19. You've got that. That's the 18. That's the 6. And then for the 14, you've got. So that's how you read. That's where you're actually seeing the code there. But do remember, each time you go up one, you're doubling the number of particles. And that's, again, the little pictures you can see if you were doing it. And that's what they're looking at doing a 4407. SDA, well, basically taking the script down, and there's a process for doing that, which again is on the website. But basically, you should start off with a clean scavenge space, steady conditions, and then build up take the drain out, and then mix up you take a large sample, mix it up, and then take a small sample from that, and then it's tested in the lab. We use the same lab bottles, we use the same sample label because it's got a section on there for it. A bit more information required, but there we are, and you're getting the same stuff in here. We don't need to repeat that. You can be told if it's contamination by the main engine system oil. This is the sort of picture that you get. You got the contaminants, etc. And this is the picture, various types of this picture. Of course, you're looking at trying to be in the safe area. If you're anyway out in that area, you're going to have to make some changes, maybe to feed rate or even to oil, to be quite honest. This was a little case study that was done by a colleague of mine, showing that if you were doing SDA, you could actually save a bit of money. This was done a while ago, so they took samples there, and then they kept reducing the feed rate, reduced the feed rate there. So they got it down, still in the green zone, still within the OEM, a bit high at the beginning, but now well within the OEM residual BN requirement. And then you see, they reckon it was saving about $19,000 a year. Not bad, and no difference. You're actually operating better. Sweep test. Sweep test is really just taking a set of scrape down analysis with different feed rates. Again, there's full details on the website, and there's also a very good recent service letter from MAN showing the whole thing on that. and it's well worth doing, you know, getting it set up, and then you know, you're much more in control of your feed rates, and that's the sort of stepped kind of process. Again, it's on the web in full, and the SDA procedures. If you have the right onboard test kits, you can actually do the analysis good enough on board. Certainly a good enough indication to make the changes. Detergents, someone asked about detergents. Again, we've got a little brief on the web, so I'm not going to go into that in detail, but basically detergents are put in for cleanliness and also for base number. And between detergents and dispersants, your dispersants keep the carbon particles, products of combustion, in solution, if you like, or in small parts. It prevents them agglomerating and coming out and blocking filters, etc. And detergency keeps them clean. Clearly, and that picture of a piston there is one that the detergency was not good enough. Equally, one of the issues with going to 0.5% sulfur fuel is that one of the contributors to base number was the detergency additives. So if you reduce the base number, you were reducing the amount of detergency. And so it's not a case of diluting a 50-70 to a 50-40. It's a case of building up. Like our ECA 50 was a brand new oil built up from the bottom with different additives because we didn't require the high BN in it. And that's what's happening with the 50-40s and for the 0.5% sulfur. So worth reading. It's a lot of nice pictures on this one, and quite a complicated concept dealt with very simply. Onboard test kits, I'm sure lots of you are familiar with this. Again, done properly, very useful. And again, it's a trend you're doing. The little visco comparator here, the only thing I would say there is both oils have to be at the same temperature, the new oil and the oil that you're testing. Doesn't matter what the temperature is. It can be in the engine room or it can be in the control room. But once you've filled up the little reservoirs at the end, leave it for at least an hour, maybe 2 hours, so that both oils get to the same temperature. Then flip it up, and you'll get a good indication. Yeah, full instructions given there, and you've got your little test papers for your blotter spot. Again, quite a useful thing to do. The idea of this is you can do it yourself, you can do it weekly, whatever, and you can test things. If you're worried about something, you can check it. Have I got water in there, or what's my BN, or whatever? These are the kind of test schedules and suites. Although it says you can check for water and fuel, I wouldn't do that because it's very messy. But if it was an emergency, you could do it. As I say, the water and insolubles done properly. Water and base number are very good indicators, and you can store quite a lot of oils in the little memory. Cold corrosion test kit is basically a go, no go. Very simple, very quick. It's a color comparator test, and you follow instructions and you can do it in literally 5 minutes. And it's one of these things, although it gives you a set of ranges, if you don't have an answer, you don't have cold corrosion. So simple as that. So it's quite handy from that point of view. Ferrous wear meter is a simplified PQ type meter. So you can use that in conjunction with the bomb, the BN bomb, if you're doing scrape down. Yeah, not as accurate, I would say, as an Analyx, but then again, it's an awful lot cheaper. But again, it's trending, it's okay. And back to my friend as a finishing, keep oil alive at 95 and you will save yourself an awful lot of problems. There are lots of other test kits you can have on board for like cat fines, which is a little purifier basically. And again, it's a no-go type gauge. If there's no answer, if you get nothing in the tube, you haven't got a problem. There are also XRF machines. and lots of other type of machines, but a lot of these, the cost is extremely expensive. You're talking 25,000, 30,000, even more dollars for one of these machines. So it's, you know, you have to have a real need to do it. So there we are. Thank you very much for your time. Apologies for going slightly over, but it was quite a wide-ranging brief, but I think I've touched on most of the things in various degrees of depth, and happy to take any questions on anything that's been said, or in actual fact on any other lubricant questions. I won't guarantee to answer everyone, but I will certainly try.
Okay, thanks, Graham. It was wonderful to have you speak so elaborately on lubricant analysis, the method of doing it, the correct procedure, what happens if you do it wrongly, what else you need to check, how you need to take precautions. So it was all very, very elaborately mentioned and very, very well presented. So thanks so much. The questions will follow concurrently when Mr. Rai does it for the next speaker. So we'll do it all together at the end. So
Yes.
With that, I will, so thanks, Graham. I will introduce the next speaker and the moderator. So the next speaker is Mr. Praveen Chaudhary and moderator Mr. S.M. Rai. Praveen Chaudhary, marine engineer by profession. He completed his training from Mazgon Docks 1982-1986 batch. He sailed for almost 20 years in the various ranks till ultimately became chief engineer on board bulk carriers, car carriers, and very large container ships. He has been ashore in maritime training since 2006 and presently working with Goodwood Marine Services as a training and technical manager. He presently conducts training on latest ME engines on a MAN built simulator. Has been involved in the process of converting company vessels to the use of the latest very low sulfur fuels and ultra low sulfur fuel, that is 0.5% and 0.1% since January 2020 when it was implemented. He has also been working toward finding different solutions to the challenges faced by the industry in optimizing the use of various cylinder oils for use with different fuels, abiding by the guidelines as set by the engine manufacturer. So that's Praveen Chaudhary. Mr. S.M. Rai, though he needs no introduction, being well-known and eminent personality in the maritime sector. However, for the sake of formality, and for those few who have not come across Mr. Rai, he's a graduate marine engineer and a fellow of the Institute of Marine Engineers. He served with distinction in various roles in SCI and INSA and is currently a senior advisor to the maritime sector. Despite his age being in his 70s, don't let that befool you. He is as enthusiastic as a small child when it comes to discussions and interaction on various topics affecting the maritime fraternity and is very vociferous when it comes to expressing his views and opinion. He is a huge asset to the IMEI. Over to you, Mr. Rai and Praveen, for the question and answer session. Thank you.
David, thank you so much. I feel flattered by your comments, but nonetheless, it's again a pleasure to be in service of the fraternity. And before we take on the question answer session, I would like to thank Mr. Graham. His presentation was indeed very elaborate. And to be honest, he covered almost all those areas where I had received several questions about the types of analysis processes that are being used in the laboratories, etc. So what I will do, I will refrain from taking questions on his presentation because as I said, he has already covered them widely, but I will first shift to Mr. Praveen Chaudhary and I will ask as a trainer and as a representing a shipping company about his impressions, not only limiting to the lube oil analysis on board or the reports of the laboratory, but particularly since 1st of January 2020, since we've introduced the low sulfur fuel, I would like to have your first opinion as to what is your overall strategy with the low sulfur fuel which is being used as a ship operator. Can you tell me what you are looking at lubricating oil, particularly with the low sulfur fuel? And I may add, almost all of us know that sulfur itself is a lubricant. And with the reduced quantity of sulfur in the fuel oil, you will have to look at additional areas, how to increase the lubricity between piston rings and the liner. So, Mr. Chaudhary, it's all yours.
Thank you so much, sir. David, sir, thank you for the introduction. Rai, sir, thank you very much. Talking about the latest topic in the market, 0.5% and 0.1% fuel. That's very low sulfur fuel oil and ultra low sulfur fuel oil. Very hot topic. Not many people have very many answers on this. We have had so many recommendations from the engine maker, from the oil suppliers, and our own experience. Today where we stand, we are still waiting for more instructions from the engine makers. In fact, we had a very large online webinar last Friday regarding this. Practically everybody in the industry, every company was being represented, and the engine manufacturers were there. The lube oil suppliers were there. And in the end, we are still learning, because there's not so much service experience available to go by, even for the engine makers as well as the lube oil suppliers. As Mr. Graham has already covered so much of the topic about the new oil and the cylinder oil issues. What I would like to add is when the new fuel has come in, it is not just the sulfur which is down. Together with the low sulfur comes in a lot of additional issues, like you are having sedimentation issues, you are having micro carbon residue, you are having oil, you're taking bunkers in the Far East, you're taking bunkers in the US, you're taking bunkers in Europe. Everywhere, the bunker oil characteristics is so different. So for the lube oil companies to come up with one solution, it has been a very challenging task. And for companies also who prepared very well in advance. I mean, we started preparing somewhere in maybe March last year. And by October or November, we were already on 0.5% fuel. In spite of having done that, taken all kind of precautions, our experience has been that somewhere, as the new fuel has come, 0.5% sulfur has come, the issue now for the cylinder oil being used is no more that of neutralization. There is no sulfur, so there's not much of sulfuric acid. And there's not much of sulfuric acid. You don't need so much BN. Okay, so you reduce the BN. So as per the engine manufacturer, they told us you reduce BN and you start operating. We reduced the BN, we started operating. But then what happened was cleanliness became an issue. We started getting piston rings that were not so clean. So we went back to the engine manufacturer. Engine manufacturer saying, oh, the BN, the low BN oils that you're using has low detergency and dispersency properties. So can you please, if you're finding it difficult, they issued a service letter. Can you please increase the BN of the oil for a short period of time? Now, short period of time was a question mark. Is it 3 days? Is it 6 days? Is it 9 days? We saw 10 days. And when you put 10 days, you opened up, liner already scuffed. So what do? And then the moment you are increasing the BN, you are also increasing the chances of abrasive wear, because you are increasing the BN because of the additional additives which are there for detergency and dispersency. The moment your piston ring becomes clean, they say you must revert back. But by the time we checked up, the liner is already scuffed. All right, they're saying, no, liner is not scuffed, liner is polished. Okay, good, polished. So what do we do? Oh, polished means you got to get it home, but you can't do it on board. You have to send it to workshop.
Mr. Praveen,
these are the issues.
in continuation, ask you, you're talking about scuffing of liner. Have you ever thought of using low TBN and high TBN alternately or at an interval of few weeks? 1 week you use low TBN oil and next week use high TBN oil to get over this scuffing issue.
Yes, sir. That is a very interesting question, sir. And that is what the service letter says. As I was saying, we changed over to high BN, and within 3 days, I mean, there are some companies who have told us within 3 days they had scuffing. So, because when you are changing over to high BN, you are looking at better detergency and better dispersency. Okay, fine. But then when high BN has come, you also have high calcium carbonate, which is limestone, which is basically your detergent that you are adding. So now when you have increased the BN, you can't just say 10 days or you can't just say 15 days. You got to be very careful when you're changing. And it also depends upon what kind of piston rings you have on board. Now, as per the manufacturers, they had said a long time back, couple of years ago, that you must change to special coated piston rings. Some companies were able to do it. Some companies were ceramic coated. Some companies were able to do it. Some companies were not able to do it. Now, where the ceramic coating was there also the outcome was acceptable. It was not great, but acceptable. But where the coating was not there, it was unacceptable. We had scuffing over there and even the rings getting damaged. So now in the webinar that happened last Friday, what the engine manufacturers have said that LUB oil guys, we need to start classifying oil as per the detergency and the dispersency number and not the BN number, because that is a wrong indication. So what happened was some companies said, okay, I will mix BN. We have this ACOM machines where you can mix the BN and you can decide, you can get a 50 BN or a 60 BN. There also, the issues faced were there is about 180, 200 liters of oil in the pipeline. By the time the new oil will come, you have not very good control on the exact BN of the oil going in the engine at that particular point of time. So this poses a challenge. All right, now you have brought the BN to a certain level. But what we are forgetting is that it's not the BN we are interested in. We are interested in the detergency and the dispersency. And as per the oil manufacturers, what now they are suggesting is that you use the highest BN available. So they are not saying low BN and high BN. They are saying 40 BN and then go in for very high BN. And that too, now many times we see that we are asking chief engineers, how often do you do scavenge space inspection? Oh, my company, I'm doing 1 month. 1 month is too much. So 1 month, you could have finished the engine by that time. 10 days. 10 days is a good thing. But then if you're changing to high BN oil, 3 or 4 days would be a good time to do scavenge space inspection.
And Praveen, that was nice, because one of the questions which was asked was the same. That how do you recommend inspection of liner and pistons nowadays through the scavenge ports, etc.?
So it's subjective. It's subjective. Every ship different.
But no guidelines.
No guidelines. Nobody is able to give guidelines. But the point is, yes, sir. What is important is the onboard SDA, crypton analysis, and the visual inspections. Now, most of the engine manufacturers, they have given a very nice laminated booklet, wherein you can look at different kinds of different conditions of the piston ring and different condition of the piston crown, of the liner surface, compare it with the photos that you have taken, and then decide what stage of damage or wear or deposits your liner is in. And then take a call, because again, for each condition, each photograph, there is action to be taken also very clearly specified in the service letters, along with the laminated booklet that comes. Excellent pictures to go by.
Have you heard any company or recommendation where ceramic coated piston rings have been recommended instead of chromium coated, what you've been using for years?
Chromium, normally we are having chromium on the top and bottom surface of the piston rings and the piston ring groove. These days we are having alu coated rings. That is for running in. And nowadays, the engine manufacturer recommendation was that you shift to top three rings only with this ceramic coating. And also now there is a proper tool available in the market called Elcometer. You can measure the thickness of the ceramic coating. And now the engine manufacturers are giving you a proper thickness also. What should be the thickness at 0.6 mm is the new one. 0.1 mm you would want to start thinking of starting the overall. 0.05 you need to change the ring. And also what happens is we have now in these rings, we have these CL grooves, which allow some pressure to be released. So your top piston ring is not under pressure, and then the second piston ring, and the third piston ring is full lock. There's no CL groove on the third piston ring. And also we have the butt is finger lock, total sealing. So all these special rings, these recommendations were given at least 2 years ago by the engine manufacturers, but because these rings come in very expensive, many makers were thinking we'll change. Okay, right now I don't have so much of a problem, but now with this 0.5% sulfur and BN40, the people who have survived are the engines which are showing reasonably less less wear is the rings, where the rings were changed, where these new rings are.
Can you tell me something about lube oil analysis periodicity with the low sulfur fuel now being introduced?
Sir,
Don't you think as a responsible ship owner, you will recommend that the periodicity of sending lubricating oil for analysis in the laboratory should be reduced? In olden days, it used to be about once in 6 months or so.
oh, sir, no way.
Yeah.
Here, so we say if you are changing fuel oil or you are changing the grade of lube oil, cylinder oil used, and also we recommend you do the sweep test. But now with the advent of 0.5% sulfur and this low BN cylinder oil, sweep test becomes non-significant, because there we were looking at getting the ACC factor. With the sweep test, we were starting at 1.2 for 24 hours, 1.0, 0.8, 0.6. We were starting at 1.4. But now what has happened is that you don't have that much sulfur at all. So sweep test was basically telling you over and above the cylinder oil that we were using for mechanical lubrication, that was 0.5 grams per kilowatt hour. Anything beyond that, we were looking at taking care of the corrosion. But now the corrosion is not there. So we don't really need to look at the corrosion part. Now we need to focus on the cleanliness part. So sweep test becomes obsolete. Now, as far as doing the test, again, that is subjective. You need to monitor your CCM, your SDA, and you need to monitor visual inspections. And visual inspections these days for new engines every 100 hours. In fact, for the first 500 hours, we are requesting charterers to stop engine and do the testing. And after that, we would go on till the alu coating went off, so that the running in was done. And then we said we go for the sweep test. But nowadays, they are recommending that even for the first 500 hours, it would be a good idea to use a high BN oil rather than BN40 oil. So, and the engine manufacturers have promised within the month they should be coming up with a new circular. So we are all anxiously waiting for that. But at the same time, trying to protect ourselves, doing as many inspections as possible to keep ourselves safe, and at the same time carrying out onboard visual inspections, onboard CCM testing, and if your company allows frequent shore analysis. End of the day, your risk, we are looking at that LUB principle. How low is as low as practicable.
Anyway, Praveen, thanks a lot to you for all your experience and what you are practicing, and outcome from your various engine makers, etc. There are some more questions. I will come back to you later. Meantime, I will to Mr. Graham. Mr. Graham, I must again compliment you for your extensive details, what you gave about the lube oil processes and all that. Actually, many of our people were very interested to know about the type of test that you are doing, particularly the ICP, inductively coupled plasma spectroscopy, then about Fourier transform infrared spectroscopy and ferrography. I'm happy that you already dealt about them in your presentation. Now, a few basic questions which have been come and we have not been able to touch is, one is related to the bacterial infection into crankcase lube oil. There have been instances which have been reported by many ship owners that the main engine crankcase oil sometimes get contaminated by a mixture of seawater and fresh water, maybe because of hole in the tank top or by leakage or telescopic pipes or something. And such a huge quantity. And when oil gets emulsified, there is always a danger of bacterial infection. I would like to know your opinion and what should be the option of the ship owners as to what they should do with such a huge quantity, because economically also it becomes rather, I would say, very costly to the ship owner to replace it periodically or frequently. About bacterial infection into the crankcase oil.
Well, I mean, the key thing is you really have to stop the water. I mean, getting bacteria in the oil, bacteria is coming from the water. You've got the temperature. It's a combination of temperature, and of course the oil is a good, if you like, feedstock for the bacteria. We generally have seen that in the past where ships were laid up or have been sat not not operating for a while, because once you get a decent temperature, you're going to kill off the bugs. But you get that, you know, kind of humidity, water in the oil. If you've got to the stage of where the oil is emulsifying, you really have to act fast and get the oil out and into a renovating tank and try and, you know, heat it up and get the water to drop out. You know, get to break the emulsion, basically. I believe there are some chemicals that you can buy that will break the emulsion. I'm not that familiar with them, to be honest. But the danger is if you continue with an emulsion, you may end up creating a stable emulsion. And then there's nothing you can do with that. The oil is not designed to be emulsified. It is, you know, and especially if you've got oil with system oil, because it generally sits in the engine, albeit topped up, and over the years, it's rare, I would suggest, that somebody changes the whole charge of system oil. So if they haven't been cleaning it properly, or it's going to have debris in it, then your chance of getting a stable emulsion is quite high, because all those little particles actually help to make it stable. It's kind of like making mayonnaise, basically. But that's why I say water is absolutely, you know, if you start seeing water in there, you've got to get the oil out. And I mean, you should hopefully have worked out that you've got water in your oil long before you get to a serious emulsion point of view. If you've had a catastrophic ingress, then really, as soon as possible, all that oil and water should be out and into the settling tank to try and you know, break it down. And then once you've got all the free water out, try and put it through the purifier to clean it up further. But it depends very much on what stage that emulsion is. I mean, getting rid of, I have to say that once you've had a bug in your oil, it's very difficult to get rid of, because you need to clean everything. You only, you know, with the construction of the sump and all that sort of thing, the pipework, trying to get it completely clean is almost impossible. You have to use a biocide or something to flush through and to try and kill everything off. I know that I had a very good description of a US Coast Guard cutter that got bugs in its fuel oil, and it took them, I mean, what they were doing to clean it, they were steam cleaning it, they were hand cleaning it, they had biocide, and they said, we know we haven't cured it, but give it, and we will take fuel again, and at some point we will have the same problem. It's very difficult to get rid of. It's one of those things where you really want to try and prevent it rather than try and fix it. But definitely, if you've got a lot of emulsion, there's probably not a lot you can do with it if it doesn't separate.
Anyway, thanks, Mr. Graham, because that was one of the major worries of the ship owners. Okay, whenever their crankcase oil get emulsified, particularly with the main propulsion engine, then renewal of oil quantity is substantial, and it has not only on time but cost-wise also it impacts. Yeah. But as you rightly said, there is no option.
I would say that this is a really good example of why you should have an onboard test kit, because you could then be taking, and I know people who use the test kit very, very disciplined manner. You know, they will take a water test on the main engine crankcase oil, system oil, every week. You know, it's like a Saturday morning job. They do the generators, they do the main engine. So that way, again, you're getting that trend. And then once every quarter, generally, most people send samples to the lab. And then you've got another check to say that, oh yeah, we're okay. So that it's about due diligence and good housekeeping. And again, keeping your purifier working properly.
Yeah, Mr. Graham, actually we are running short of time. Yeah. Though I will have a lot of questions, but probably we will answer them to individual. One common question which has been raised by many people is about the additives that are being made into lube oil. With the coming in of low sulfur and high demand and high expectations of the lubricating oil, now various type of additives are being added into lubricating oil. Don't you think it does affect your analysis reports? Because most of these additives which are there have some sort of chemicals in them, and they do affect your analysis reports.
Not really. I mean, as I say, we know what's in the oil, and I agree that we are testing all manner of new additives in order to get the performance in terms of, you know, a much higher performance level in terms of cleanliness and lubricity. But to date, nothing is seen as really affecting the core parameters, especially with, you know, some of the analytical tools. All it does is show everything that's in there, so you know what's in there. I mean, we take if you like, a footprint of what an oil should look like, and we have one of those nice graphs, and that is the picture, and then you can superimpose on top of that another graph of oil and see whether or not everything is okay. So we're not seeing that as yet, but we are using some interesting technologies now in terms of not just the traditional additives, just like you know, trying to go for ashless and things like that, and exploring a bit like the fuel oil people have had to use different components, different streams from the refinery to get down to 0.5. We are in the similar position, starting to look at different chemical additives that are dealing with the cleanliness issues, shall we say, the lubricity issues, rather than the BN, which has been the driver for decades, basically. So, but as yet, no, we're not seeing any noticeable interaction that would have changed it. And to be honest, if there was something that had a change, that would be factored into the analysis program. We'd compensate for that, so it's not a problem.
As a manager of your recent appointment in Gulf, will you have any comment of increasing number of catch fines now? Because that's another issue which is damaging most of the running surfaces, particularly piston, liners, etc. So
yeah.
Do you have any comment on cat fines?
Well, the cat fines is, it was always known that when they moved to 0.5, that cat fines, the incidence of cat fines would increase, just because of, if you like, the refinery process and fuel process they had before for standard heavy fuel oil, and compared to the streams that they were taking. There's also, I guess, the issue of they should hold this, you know, in the refinery, they should hold it to let the cat fines settle out, but they're not using the same streams, and although one test lab has actually indicated they're not seeing high cat fine levels, what they're actually seeing is that the cat fine levels have increased. So you're nearer to that limit now, rather than before when it was much lower. Again, you can get, there is an onboard test kit that can check for cat fines. All that says is if you've got cat fines or not, or how much cat fines. And then basically you've got to take some steps on board, whether or not that's trying to settle them out, clearly purifying, but it's definitely something that's in there, and we are seeing that people are having, you know, especially when you do a liner inspection, the actual you know, liner surface, excuse me, you can see, even with a small microscope attachment, you can see the embedded in the liner material.
Interrupt and ask you particularly about this new additive boron. I'm told boron is being added nowadays to reduce the friction coefficient. Do you have any comment about that additive?
Yeah, that's been used, but there's no, all you'll see is that, I mean, it's all been used in certain oils, not in all oils. and you will see, and it depends on who the manufacturer is of the additive. All it is that you will see it in the elemental analysis, but it generally won't be very high in, you know, maybe, well, it'll be high enough, I suppose, maybe 300 parts, but in a lot of others, it'll be a lot less. But it is being used, but it's there, and we know it, and it shows up, but it's not having an effect on anything else.
Graham, thank you so much for your detailed presentation of this. I'm being told that you are running short of time. So
Okay.
I will answer the questions now. And what I will request for your complete submission of the program, if Mr. Girish is around, he's our head of the technical seminar subcommittee, probably he will give. And there are some questions which are left. I have not been able to raise them. Probably we'll come back to you and answer to the respective participant today. So thank you so much to you as well as to Mr. Praveen Chaudhary. Nice to have you with us today. And it was really a pleasure interacting with you. Thank you so much.
Thank you very much. Thank you.
Thank you, sir. Thank you very much.
Yeah, thank you, Mr. Graham, Mr. Praveen, and Mr. Rai for a very engaging round of discussions. There were quite a few takeaways from today's session. Mr. Graham, in his presentation, touched on the importance of lube oil analysis and how taking timely action from these reports helps reduce unscheduled downtime of machinery and, more importantly, costly failures. Mr. Graham also emphasized on the important basics related to sampling procedures, from where the sample should be taken to get a true reflection of the lube oil in use and how it should be stored, importance of the information to be given like machinery details, running hours, etc. Very fundamental things, but very, very pertinent. Then, of course, he also touched on how to read the report and what to make of the results. Then test methods, international standards, which forms the basis, effects of various contaminants on the lube oil itself or machinery, importance of using the purifiers correctly. And I remember the 95 degrees centigrade. I hope all the other members remember this. Then, of course, Mr. Calder also elaborated on the scrap down analysis, which was also touched upon by Mr. Praveen during the question and answer session, and the advantages of doing same and importance of doing some simple onboard analysis of lube oil using mini test kits that are available. Then we had the question and answer session. Mr. Praveen focused on the impact of cylinder lube oil after the start of use of low sulfur distillate fuel and the associated challenges. Mr. Praveen rightly pointed out the challenges for lube oil manufacturers to cope with the varied types of fuel oil now in the market after the use of low sulfur fuel oil having been made mandatory. He also, as I told earlier, he emphasized on the importance of scrape down analysis, significance of analysis of scavenge space oil, increased under space inspections in the present scenario. Of course, we had other pertinent questions on the impact of additives on base composition of lube oil, increased CAT fines in fuel oil, etc. As Mr. Rai said, we have more questions which we could not take. We are already almost 25 minutes behind schedule, but we will do our best to individually reach out to the members with answers. And we had, I think, continuously right through the session, we had more than 200 participants. And considering the interest in this particular session, we will definitely look into hosting another session after a few months. I will now request Mr. David to take over and give the vote of thanks.
Yeah, thanks, Girish. So with this, we conclude today's seminar. First and foremost, would like to thank Mr. Ramakrishna Alluri, Fleet Manager of Chelaram Shipping Hong Kong, who introduced us to our sponsors for today's webinar. namely Gulf Oil Company. We are immensely thankful to Gulf Oil Company for agreeing to sponsor this event, and indeed to Mr. Graham Calder for agreeing to speak on this very relevant topic of today's times. We are thankful to Praveen Chaudhary, who was kind enough to be present to answer so many concerns and queries related to this topic. Of course, we have not done justice to all the questions, but we will definitely answer them offline and send a response to the people who have sent us the questions. Rest assured about that. We will not leave any question unanswered, which is normally our trend and tradition which we do. We are thankful to Mr. S.M. Rai, who is always in the forefront when it comes to such events. And despite his involvement in multifarious activities, is present to actively support and guide us. Indeed, as always, Mumbai branch chairman, Mr. Jain, who is so enthusiastic and is involved to ensure all things fall in place. Of course, the technical subcommittee led by Mr. T.S. Girish, country manager of DNVGL, for organizing this event. I cannot end my vote of thanks without making a special mention to the behind the screen personnel who took all the efforts to make this possible. First and foremost, Sanjeev Mehra, whose tireless efforts and innovative ideas always make the session interesting and without glitches. Comrade Bhupesh Tatar, who is on the job around the clock. Ms. Nita Nair, who unfortunately couldn't be part of this seminar because of power failure, but who has done all the background work for organizing these things with her usual promptness. So Sunen Sanantani and all the rest who contributed to make this event a success. Last, but most importantly, we are gratefully thankful to all the participants for being present in such large numbers, which has been instrumental in making this session a phenomenal success. Wish you all a
So we lost you, I think.
Yeah, I think we lost.
We lost him. Okay, so I mean, he's almost finished thanking everyone. So let's take the polls now and just share the polls. So request everyone if they can give a feedback.
Mr. Mehra, can we vote?
Yes, sir. You can, sir.
Mr. Rai, we will not be able to vote.
I can still see people voting, so I will wait for a few seconds more.
Mr. Ramakrishna Auri said he cannot vote.
I managed to vote, sir, now. Thank you.
Yeah.
I think others are also experiencing problem. The submit button is not getting active sometimes. I think they have to change between their one of the options and then it gets activated, like monthly to quarterly or whatever they wish to.
Okay, so we have almost 87% people voting. So I think we should get on with the next agenda. Okay, I will end the polling here and I will share the results. Bhupesh sir, if you can just Okay. So we go on to the next item on our agenda, and that's the last one. Request everyone to please stand up for the national anthem. I will just try to get the
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
right. So thank you, everybody. So with the permission of the chairman, can we end the meeting?
Yes, we call the meeting to a close. Thank you everybody for being here and for participating. Till the next one, please wait for the next seminar and do join in and give us all your support. Thank you.
Thank you very much. Thank you for the invitation.
Thank you, Graham. Thank you so much. Thank you.
Bye.
Bye.
Thank you, Graham. Thank you.
Thank you, sir. Thank you, sir.
Thank you, everybody.
Aluri, if you are there, thank you very much.
Thank you.